In this video, we're going to work through a problem about related rates. First, let's look at a statement of the problem. We're told that a man walks along a straight path at a speed of 4 feet per second. A spotlight is on the ground 20 feet away from him and stays focused on him. Now we're asked at what rate is the spotlight rotating when the man is 15 feet from the point closest to the spotlight. The first step in solving the problem is to identify the relevant variables and to find an equation relating them. It really helps when we do this to first draw a picture describing the situation. So here's a picture that we can draw. We have the man walking along a path to the right. We have the spotlight down here. The dotted line represents the beam of the spotlight. So let's label the picture with the information that we're given. So first we're told that the spotlight is located 20 feet from the man's starting point. We're also told that the man is walking at a speed of 4 feet per second. Now let's fill in the rest of the information by adding the variables to represent the quantities we're measuring. First, let's label the distance the man's traveled from his starting point by the variable x. So x is going to be the man's distance from the point on the path that's nearest to the spotlight, and it will be measured in feet. Now we're concerned with the spotlight's rotation, so it makes sense to denote this angle here. We'll call this theta. So theta is the angle between the light beam and the perpendicular path to the wall, measured in radians. Now we'd like to write down an equation that relates my two variables. So we notice here that if I look at the tangent of this angle theta, I can write that down because tangent is just given by opposite over adjacent, which is just x over 20. Or another way of rewriting this equation is I get 20 times the tangent of theta is equal to x. Now in step 2, I want to differentiate both sides of the equation with respect to time. So here's my original equation, and I remember that all of these variables are actually functions of another variable, time. So I can differentiate both sides with respect to time. But I have to remember my chain rule here. So when I take the derivative, I get that on the left-hand side, I have 20 times the derivative of tangent, which is secant squared theta. But from the chain rule, I have to multiply by d theta dt. And on the right-hand side, the derivative of x is just 1, but then from the chain rule, I also have dx dt. So now I have an equation relating two rates of change. My final step is going to be to solve for the desired rate of change by using the information provided. So I can solve my equation for d theta dt. I get 1 over 20 secant squared theta dx dt. Or I can also write this as 1 over 20 cosine squared theta dx dt. Now I need to plug in the information that I'm given. So recall that I'm told that x is 15 feet and that dx dt is 4 feet per second. So I know this quantity here, dx dt. I still need cosine squared theta. To get that, let me set up my triangle again. I want the cosine of this angle here, theta. Remember that the spotlight is 20 feet from the starting point and that the man is 15 feet away from that. So I can use the Pythagorean theorem to fill in the third side. I get the square root of 15 squared plus 20 squared, or 25 feet. And then I can use that to find the cosine of theta. Cosine is given by adjacent over hypotenuse, so I have 20 over 25, or 4 over 5 feet. Now that I've cosine theta, I can go ahead and plug in all of these quantities, and I get that d theta dt is 1 over 20. Let me remember my units here. I have 1 over 20 feet times cosine of theta, 4 over 5 squared, times dx dt, which is 4 feet per second. And now I can just go ahead and evaluate this number, and I get an answer of 16 over 125 radians per second. So that's the rate at which the spotlight is rotating, and I've answered the question.